Example number 1. Guess the value of limit of x minus 1 over x squared minus 1 when x approaches to 1. We notice that this function is not defined when x equal plus minus 1. We will plug in the points. We will use the table. And you see that those are the numbers that less than 1, that near 1 but on the left side. And those are the numbers that near 1 but on the right side. Let's notice the two numbers 0.9999 and 1.0001. The value for the function f of x approach very close to 0.5. So we conclude that the limit of the function x minus 1 divided by x squared minus 1 when x approaches to 1 equal to 0.5, or you can write 1/2. In example number 2, we also have the table and we have the value t squared in the function is when you plug in the t positive or negative, it gives us the same value. So in the problem, they combine. To make it short, they make plus and minus. So when they make plus and minus, when you square the t, you get the same answer anyway. So we get the value, t value that close to 0. And you notice that this last number plus minus 0.00001 give us the function f of x is almost like 0. Just like the example before, we may think the answer is 0, but that is not true. The reason why is that because 0.00001 is very small. When you take the square root of 0.00001 square plus 9, this is almost like 9. It will give you 3.0000 and something. And minus 3 is almost give you the answer is 0. And then divided by something, then the answer will be 0. The problem is that the calculator, the regular calculator, does not have enough space to carry a lot of 0. So it will give you the answer as 0. And the end final answer for the function f of x will be 0. It's just because of the calculation. However, when I check with the scientific calculator or the graphing calculator, the answer for this, because we have more space in the scientific calculator, so the answer is still 0.167. So the final answer for this problem is 0.167 or 6666 and so on. Then we can write this in the fraction form. This is like 1/6.